Well, hello, ME201. This is Professor Hoover coming at you from my home kitchen. I'm going to be doing a walkthrough of the setup for Lab 2. This is the smart garden where we're actually going to control the fluid level of water in a tank using the moisture sensor that we calibrated in Lab 1. You'll, of course, be doing this in the lab computers, but I brought home several of the resources from the lab today, and I'll be showing you how to do it. So you're going to be recording a video eventually, like this, that's demoing the lab. And so I'm just going to get started and show you kind of what the layout looks like here. You'll have similar equipment in your lab. So first of all, we've got our little Arduino battery moisture sensor, the IoT Maker carrier, the cable for that, the battery power, USB, and of course the case. We're not really going to be using the case much. That's what we did and introduced in the moisture sensor calibration lab 1. Now we're going to introduce a tank. The tank has a pump inside of it and a tube connected to that, a fan, and a auxiliary tank that the tube is connected to. We'll also you can take a look at the pump and what it looks like before it's installed in the tank, as well as tubing, a funnel, a secondary beaker of water which we'll use to fill the tank with, some jumper wires, some motors, small DC motors. These are brushless DC motors. Sometimes you'll have a breadboard and some jumper wires. Now, this is just a quick example of a home plant that's growing in a tank of water and a hydroponic garden, if you will. What we're going to be doing is regulating fluid level in a tank just like this. We don't really need the plant at all for the purposes of what we're doing today in lab, but that is the gist. Now, the setup here is going to be, I'm going to use this phone camera to monitor most of what I do. We're going to go back to lab 1 and look at some of the setup that maybe we skipped uh, uh, for how we used the Arduino Cloud to program this guy. Then we're going to take it from there and step through the lab. There are slides, and those slides really do walk you through with instructions and a procedure and give you the background. This video is intended to kind of show you how to do most of that setup step by step. So it's going to be a longer video, really for those that really want a detailed walkthrough if you're having trouble or you need diagnostic help as you're working on this lab. So I'm going to pause this, switch my gear, and pick it right back up. Okay, so I've set up my camera facing down on the counter, and I've also got a camera on my laptop facing me. I'm going to turn this off in a moment because this camera isn't great, but you can see I've got the Moodle page up here, and we're gonna take a look at some of the resources and then step through the lab. I'll turn off this camera here now. So on the Moodle page, we had assignment 1, and in assignment 1, we had some slides. And essentially the core of that, after looking at a measurement system, was calibrating the moisture sensor using a height gauge. And we made a table with height and moisture millivolt output, downscale, upscale, downscale, downscale. Now you use that a bunch of error analysis and instructions for your assignment 1 to analyze that data in all the possible variants of it and do a verification test on the height gauge and do some plotting and things like that. Now we're going to look at how we're going to use that data. Now, so we're going to jump back to the slides and go to week 2. Now, again, each of these chapters is tied to a chapter in the textbook. This one's on static and dynamic characteristics of signals. So we're focusing on how to use the signals in this measurement system to act in a feedback loop to control water level. Those signals have some dynamics to them, which we'll see as we walk through this. So do check out chapter 2. And of course, there's going to be slides here for slides for week 2. The video or the image to explain what we're going to do is shown here. We're essentially going to have a simulated passive rain barrel inflow of water into a hydroponic tank that's in a greenhouse, trying to grow a plant. And that water level needs to be controlled, specifically because the rainwater is unregulated. The tank could actually overfill, and we want to prevent that by regulating that pump on and off to keep the water level below a certain level. We're also going to use the lights and the fan to simulate environmental controls for a typical garden application. So again, focusing on signals and using the moisture sensor. We'll come back to some of this theory later on, but we're ultimately going to use all of these components, including tubing, pump, and fan. And we're going to be using this tank-based experiment with a funnel and an auxiliary tank that we're going to be pumping water out of. We're going to do a dashboard using the Arduino Cloud and modify an existing urban farming tutorial or course that's already in there extensively. And so you're going to see these slides cover all of the step-by-steps, including setting up relays and modifying variables, and ultimately improving the calibration with using a log linear relationship and then recalibrating the sensor for the tank. A bunch of details that we'll get through eventually, including making a Christmas tree gauge that follows the LEDs follow the water height. And in the process, there are a bunch of steps that are in this single page that tries to capture in a consolidated form every step that we're going to follow today. So essentially, we're going to try to go through this step by step so that you can follow it as well. Now, this is going to require some diagnostics, and so be sure to note if your things are not working, some of the tips that I've provided for you here. But going back up to the top, what we're going to start with is actually taking a look at the Arduino Cloud. Now, your system will be essentially the Clarkston Computer Lab, and your system, just like any of the other computers around, can actually log into the Arduino Cloud. And so we're going to do that as a first step. So Arduino Cloud is called app.arduino.cc. And in here, there's different accounts that you can log into. So I'm going to sign out first. And you can see that we have 10 accounts for the Clarkson lab, the MAE lab. I'll just choose lab 6 here, just assuming that I'm at station 6. And I can put in the password here, which is Golden Knights 2023 ! I think. And we'll see if that logs us in. Okay, here we are. We're in the cloud dashboard. And so there's a bunch to get familiar with here, and I think you will you'll see that little by little as we walk through this. But we'll start with the side panel here, which has a bunch of options. Sketches is where there's code, C++ code for programming the Arduino. Devices is any Arduino devices. Things are the configuration name for what we call the Internet of Things. It's really a configured device with variables that we'll program. Dashboards that allow us to monitor signals and control sensors, triggers, templates, resources, and courses. Now, the course that we're going to primarily use and start from is called the Explore Internet of Things kit right here. Okay? And this course has different activities, and it's really important to go through the Get to Know the Kit activity, which gives you some background. I'll hide the teacher notes here. The background of Internet of Things, the Arduino IoT carrier with the Arduino Maker 1010 embedded in it, and all of the different sensors. How to collect data, starting out with temperature and humidity data. Some of this was programmed into the IoT carrier for you for week 1. And so this is some of the background here. And it goes into some of the code for Arduino and how the code works in generally in Arduino. There's a header section, usually bringing in libraries. There's what's called a setup. It's kind of like the main program. And then there is something called a loop that, the name suggests, loops through iteratively until the program ends whatever commands. In this case, the loop has us reading temperature and humidity from the carrier, the IoT maker carrier, printing them to the serial port, and then also printing temperature and humidity when we touch buttons here. So actually, this is all somewhat part of what was programmed into Lab 1. But also in here are several other modules. And Urban Farming 101 is the one that we're going to mostly build off for this class, where we use relays, and then we modify that with the moisture sensor to control water level in the pump, in the tank, I'm sorry. So going back to the Arduino Cloud, though, I want to go back to the original sketch that's in here, if there's any, and there any devices that are in here and things. And we see that there's not much in here. There is a device that we're going to want to remove at first, like that. And there's no sketches in here. So where does the code come from? Well, first I want to go back to just connecting up the IoT maker carrier. So I've got the IoT maker carrier here, and I'm going to go ahead and unbox the Arduino Nano. Okay, and go ahead and mate it up. USB end connected to the same end of as where the white relay boxes are, and then very gently and carefully, making sure the pins aren't bent or anything like that, pop this guy in like that and snugly join it together. We'll take this little black and red battery jumper cable, and we'll connect the Arduino maker carrier's battery terminal to this white connector here, labeled power, to the Arduino Nano. That essentially allows us to use the 3.7 volt lithium ion battery to power this guy. Now, we can plug this in. We also can plug in our moisture sensor. So we have snap in that way, get the other end of our cable to pin A5, and now we're just about ready to connect things up. We're not going to use the case, so we're going to put that to the side, and we're going to go ahead and look for our positive on our battery terminal, our positive on our battery clip, and plug that in. And we see the green light here for the Arduino and the power button coming on here. Now, when we first flip this over, we don't really see any particular action going on, just some yellow lights. And so what we always want to do is reset the Arduino, okay? And because it was already programmed for Lab 1, this is the one where we have buttons that show temperature, humidity, moisture sensor, pressure, and light. And we saw in Lab 1 that as we tinker with these things, we get different readings. Ultimately, we got a beaker of water, and we looked at our moisture sensor, 1023. We put it in water, and 893, a little deeper, 876, and so on. And that was the basis for our calibration, putting this moisture sensor in water and figuring out the water height relationship to moisture sensor. So the question is, how did this guy get programmed this way? And so how does it actually work? Well, the truth is we plugged in this USB before that we did this, and we loaded a bit of code in already. So if we go ahead and plug in the USB right there, I just connected the battery just for convenience, and then plugging in my USB to my computer. I now see my lights click on again, and if I want to, I can reset that, and you see the little screen flashes. That's kind of an indicator that things are working here, and away we go. So on the Arduino Cloud, though, one of the things that's kind of interesting is if we go and look at sketches, there are no sketches in here already, and there's no devices in here. So where did this come from? Back in the class Moodle site, we actually included under Lab 1 the code that we used called IoT Lab Week 1 right here, uh, embedded into the Moodle website that included the code that explains how this particular functionality began to work. We include the Arduino Maker IoT carrier.h, a header file here. We declare the variable temperature as a float and humidity as a float, setting the initial value to 0. Moist is an integer, pressure is a float, light is an integer, and we define RGB for our light colors also as integers. In here, we have the void setup, the beginning of the Arduino, one of the two main sections of the code. We set up a serial connection at 9600 baud rate, and then we set the carrier case to false because we're not using this carrier case. It's important to do that because all the buttons and sensors don't work quite the same when this is set to true. Then we just run this carrier.begin function. That's in the setup. In the loop here, the first thing we do is we read the temperature of the temperature and humidity sensor using this function, carrier.env.read temperature. Similarly, we read the humidity, okay? Read humidity. We also read from pin A5, then analog read is reading the voltage from pin 5 that corresponds to the moisture sensor. We read the pressure, and we also have this little while loop in here with a delay that actually reads the light sensor as well. We do this carrier.buttons update function, and then we print to a serial port temperature, new line, and then degree C, humidity, moisture, and so on. And then we also have some functions down here that that show us what happens when we press the 0, 1, 2, 3, 4, or 0, 1, 2, 3, 4 buttons, which are the capacitive touch buttons. 0, for example, is temperature. And you can see that there's a print temperature function in here that's included after the void loop, and it's just its own function, void print temperature. What does it do? It displays on the carrier a red background and then sets the color to white for text, and then the size of the text to 6, sets the cursor display, and then prints the word temp, colon, space, and then a little more down, moving the cursor down, and prints the word temperature in C. Similarly, for humidity, we see that we have a blue screen, change the size a little bit, and print the variable humidity, which was read from our environmental env.carrier function. Similarly, the moisture sensor, pressure sensors, and the light. Okay. Now notice a few things about the syntax of this Arduino code. It is C/C++. It's kind of a custom code for Arduino, but because it's C/C++, there's some important characteristics, including brackets opening and closing the main functions setup and loop. And every line needs to end with a semicolon. If you don't do that, your code won't compile and won't quite work right. So I'm going to go ahead and press add to sketches. And because I already have the cloud editor open and logged in, it went ahead and added IoT Lab Week 1 to my sketches over here. Okay. So you can see that right here. It automatically added in. It shows when it was modified and so on. So we'll just go right in here and right in here. And again, all of this is shown here. Now, this thing indicates that there's a USB connected to COM port 21. If I disconnect the COM port, it should disconnect that, and it was detached. Okay, so I'm going to connect it back up and see if it automatically recognizes it. So it automatically recognizes an Arduino MKR Wi-Fi 1010. So we'll just close that. This little connection here shows that this is working. Now I haven't loaded that code in here. I haven't reloaded it in or haven't reset the Arduino, but I will point out that you can see if it's working by looking at the serial monitor. This is through the USB connection, and it displays the values of some of these sensors. Now, some of them appear to be working, and some don't. So this is scrolling, sampling data all the time. I'm changing the moisture sensor by holding it. I'm also covering over the light, and that does change it. But we certainly see that the temperature, humidity, pressure are not working. I'm going to reset this button, and we'll see if the serial port doesn't now naturally begin to pick up. So now there's some of these mysteries with the Arduino products, and sometimes they do this kind of thing and need to be reset to work, like this case, and sometimes they don't. Um, and so again, our functions are now doing all that they were doing before. All the buttons respond. But we also see, interestingly here, that whether or not we actually press one of those buttons, we can see these changes over here. So if we were to have been doing this lab without this button working, right, we still could have seen, as I changed the moisture sensor, capacitive uh, sensor there by touching it, we can see the moisture sensor changes or the light changes, or if I put my finger on temperature, you can see that it raises again. So this is just important to note that this is how this works. In order to actually load that code, I had this code written. I first verified it, and verifying is essentially just checking that the logic, the syntax works correctly, in line with the Arduino C++ compiler. And then once it's verified, you'll see notes down on the bottom as it's progressing through. And green is good, greenish blue is good. Red or pinkish means that there's some kind of error that you'll need to troubleshoot. Here we're done, but we still haven't uploaded this code. And so we can press upload here. And now what's happening is that code is getting flashed to the microcontroller, flashed to the Arduino. If we were to have changed the code, that would then result in a change here. After a short period of time, it shows that it's correct, and this is asking us to reconnect the COM port here. And if we go around and press these buttons, we could see things are working. If I wanted just to see how this works, maybe I could make a small change. For example, when I press temperature, we got a red screen in the background. Maybe I want to change that a little bit, and do something a little bit different. Let's see, pressure, moisture, humidity. So maybe I just change this. I'll take the blue and I'll put it up here, change that guy. And then now I'm gonna live dangerously and I'm just gonna upload it without actually verifying it. And we'll see if it goes through the same process. What actually happens is while uploading, it will actually verify the code, and it won't properly upload if it doesn't first verify it. So there's not much danger in that. But now I'm ready to go. And now instead of getting red, I have blue, just like I have blue for humidity, green for moisture, but blue for temperature. And if I were to hold my hand over the temperature sensor, that number should start to go up, which I see it's doing little by little. So that's the basics of Arduino code and how this works. To get familiar with this, the best thing to do is to go through the Explore IoT Kit courses, including the activity Getting to Know the Kit and Graphing Data in the Cloud, Storing Data, all the way up to Urban Farming. Okay, so we're essentially going to use urban farming as our baseline, and so we're going to come back here, and we're going to see that to do that we're going to have to set up a device, and create some things and think variables, and then create a dashboard. So one thing I'm going to do is look at the devices, and I'm going to see right now there's no devices connected, formally connected to the Arduino cloud. There was a device and there is a device connected to the serial port, but it's not registered on the cloud. So I need to add a device. Now, in doing this, there's some step-by-step selections that you'll work through, starting with just selecting Arduino boards and then via serial USB. Okay. This will recognize your device if the USB is connected. In this case, this one is connected on my COM port 21. I'll select that and then I'll do continue. The Arduino maker will automatically randomly choose a device name. I'm going to change mine just to my name, Hoover, or you might put in here section, let's say 20 group 1 or something like that. So whatever you choose, a name that you can recognize. It's really important that you come up with a unique name. If it's not the random one that's generated by Arduino, you'll want to definitely use something that you can remember because there's going to be 10 other groups working in lab, and sometimes it's going to be easy to accidentally pick up someone else's device. And so you'll want to register your device with a name like your section number and group number, maybe one of your names or the initials of your team, something like that. Now, this is going to go through a setup routine, and depending on how your computer is set up, it's going to ask you to install something called the Arduino Cloud Agent. Okay, so mine is actually done and didn't need to do that. But if yours requires setting up the Cloud Agent, it's important to note that you can do that on your computer in the lab if you're logged into the user one local account. But you first have to run make me admin in order to install the Arduino Cloud Agent. And if you do go through the process of installing the Arduino Cloud Agent, if for some reason it gets unmounted or uninstalled when you go to run your code, you're going to want to make sure that you do that and put it in the local C directory when you install it. That way it won't get stuck in an app roaming folder that will then probably disappear in a day or two. So we've got the device here, and one of the things we could do is we could actually connect it on Wi-Fi, like my local home Wi-Fi. In the lab, you'll connect it to the PC lab that's the wireless PC lab that's a part of the lab, and there's some information about the account and login in your on your desk, and then also in the instructions provided here. So we're going to take a quick pause. Okay, we're going to pick right back up, and I've jumped over to the slides where I've looked at the measurement system components here, and I just want to go over a few things first. Before we start working through the lab, I want to just show this pump here, and the pump which is actually installed in the tank already with a tube. You're going to want to just go ahead and check that pump works. One simple way to do that is to take the black and the red, negative and positive, and connect that up to the battery, and just to see if it actually works. So if your leads are not long enough, you can take a little jumper wire, a little alligator clip, and connect it there, and then negative on the back side here of the battery, and then we'll at least listen for the pump to work by putting the battery to the pump. And I can hear it and see it moving. There's a little impeller underneath that is a centrifugal pump that's moving that will pump water. Now, this is a pump that I have on the side, and just to make sure the pump that's in my tank is working, I'll do the same thing. Now, this particular one has this pump here, has some jumper wires that are a little longer here coming out. So again, I'll just take my battery and take a look at put the wire from the negative side to the positive side, and I can hear that pump running. If I had water in here, that'd be moving some water out. So I'd want to make sure that I had my my tube connected into a reservoir tank so that it's actually going to direct that water someplace correctly. Now, also, I can do a quick diagnostic check of the fan. Now, the fan is just a little tiny computer fan, but it is a brushless motor in here, and so polarity does matter. We have a little white one and then a little black one. And when I cook up the black one, just using the red here to plus and the black to minus, you can just barely see. I'll put this on again. Just barely see this motor running. And this one is actually not running, or at least the wire is clipped a little bit. So gonna be put this one to the side. Now there is a motor on this tank that's installed right here, and I've got my black negative for the motor and then plus. And you might not be able to see it or hear it, but that little fan is now spinning. Quick diagnostic just to make sure our hardware is working. If you happen to have one of these white fans, you can similarly connect up the wires and see or hear that motor moving. This one's a little louder, a little more powerful. You can see it and hear it. So good diagnostic check, making sure our tube is working and our tube is connected to our pump before we get started with the IoT maker carrier fluid level setup. So we'll clean up the station here and just go back to the slides. Now we're going to be implementing Urban Farming 1, or Lab 1 is going to be implementing urban farming. It's actually called Urban Farming 101. There's a link to this course here, and it's the one that I had up here before. Now, it's important to note that there's actually some instructions step by step that are in the bottom of these slides that will make it easier if we actually just follow one line at a time as we're going through. And that's this thing that says lab number 2, step-by-step instructions. I've got a PDF of that going on the side. And so what I'm going to do is just as I walk through this lab, I'm going to highlight or check off each section as we go. So I'll switch over to the PDF version. And I've got my highlighter set just to keep progress. First step, connect the Arduino Maker Wi-Fi 1010 to the Arduino Maker IoT carrier. So that's already done, and the power cable is right there. Okay, so I'm just going to highlight that. Next step, connect the USB cable from the Arduino to the PC. So I've got my PC, my USB cable, and check. Now, this is going to obviously only be programmed with the previous Arduino that we file that we uploaded, but that's what it is. So next step, log into the cloud arduino.cc for the lab PC, number, so 0102, using the username Clarkson MAE Lab 0102, whatever it is, and then the password Golden Knights 2023 exclamation mark. So we have we've got that going, and that's right in here. We already logged in. We're on account number 6 here. So we'll go back and we'll just highlight that this step is completed. Right there. Okay. Under the Devices tab, delete any previously installed devices. Now, I just installed this, but I do want to point out that I want you to go ahead and delete that. So there's usually a little button over here that pops up when you hover over it. Delete that device. If there's a previous device in there, for whatever reason, it's a very common cause for your system to not work if you aren't sure exactly which device that you're loading your code to. So we've just always come back to the fact that if we do this step where we delete any previously installed devices, it just all works better. So please don't skip that step. Now, redo what we did before, add device, select Arduino board, and press configure when the Arduino Maker Wi-Fi 1010 is found, and name the device. So we'll come back to this guy. We'll go through that same process we just did a minute ago. We have a little bit of a different interface here. but you get the point. It's actually walking us through each of these selection steps. And I'm going to call this Hoover home. Okay, and check. Goes through its configuration process. You'll maybe hear the relays click, maybe see some lights click on and off. I'm not exactly sure what that setup process is doing, but it is part of making this thing work. It's goes through this little configuration utility. It says here that it can take up to 5 minutes, and I've only seen one or two devices where it takes that long, maybe the first time. And so now we are set up with that device. We're going to go back to our instructions, and we're going to complete step 5. Okay. Now we're going to connect the moisture sensor to connector A5 with the 3-wire cable installed. Install the moisture sensor on the tank. So this is kind of a two-part problem. So this moisture sensor here, the one that we've used from Lab 1, has this little bar on it, and that has these little Phillips head screws holding the moisture sensor onto the bar. We only needed that bar for our height calibration, or our height gauge connection. So you loosen those up, try not to lose the screws, and now you can separate that out. Now the moisture sensors, there's version 1.2, which is the one that we want to be using here, 1.2. If it's 2.0, it's probably not quite the right one. On the tank here, we actually have a little bracket on the tank, and the bracket has two little plastic screws that you can similarly put the moisture sensor. There's a slot in here. And so just like we lined up the two screws here, we'll slot this guy down, get these screws loosened up a little bit first, and then put our moisture sensor down. We don't want the electronics and the signal conditioning to be touching the water. So we do want the circuitry that's on the top of the moisture sensor to be above the water. But we do want it low enough so that we can actually get a decent depth into the tank. So this guy won't go all the way to the bottom, but about right there is where we've got this configured. Another point is you don't want these electronics, which conduct electricity, to be mounted to this metal bracket, because then they won't work. So they need to be facing out. So now that we've got that, we're going to connect up the jumper wire first to the moisture sensor, and then to pin A5 on the back of the maker carrier. Okay. So now we have completed step. Try to undo that a little bit. We've completed step 6. So we're just going to highlight it here. Now, step 7 on the procedures is a multi-step process that involves completing lab number 1, Explore IoT Kit course Urban Farming 101. It says add thing renamed Urban Farming, add IoT cloud variables, humidity, temperature, light, moist value, relay 1, relay 2, RGB color, and update display. Associate the connected device, configure the Wi-Fi network, add a dashboard named Urban Farming with switches, gauges, charts, and indicator values linking each of the cloud variables. Link the moist value variable with a moisture millivolt gauge ranging from 600 to 1200. Add a temperature chart and rearrange the dashboard. Copy paste the Urban Farming 101 course code into the sketch. Add a code line, moist value equals raw moist value. Verify, upload the sketch, and verify the sensors and dashboard functions work properly. Whoa, that is a lot of work there. So we're gonna take a look. The first thing is to add a thing renamed Urban Farming, okay, and then add cloud variables. So this is actually following along the Explore Internet of Things Urban Farming 101 activity. So we're going to scroll down because there's a lot of this that's already configured. We're actually going to jump over the part that explains how the relays work. We'll come back to that later. We will need those. And then we'll get down to the part where it actually is configuring the cloud variables. We've actually already done the moisture sensor measurement as part of the previous lab. So we're kind of familiar with how this thing works. So now we're down to configuring the cloud in Arduino Cloud. We've connected our device and we're going to add our variables. These are the variables here, but first we need to create a thing. So back over here under the Arduino Cloud, we go to thing, and then we do create a thing, okay? So this thing, we're going to retitle the thing Urban Farming. And this is actually an important point, again, to make sure that you're keeping track of which one is your thing versus someone else's in the class from a different section. So I'm just going to append Urban Farming with my name, Hoover, and so you can see what that looks like. We're going to add variables, okay? So this interface, we have a name, and then we have a variable type, and then a few other notes down here, like whether the variable is going to be read and write, and how the variable is going to be updated. It's going to be updated either on a change of the variable or periodically. So this was actually all documented in this table over here. So humidity is a variable name. Float is the type. Interaction is off. Read only. Display humidity. It requires a little bit of interpretation of this, but at the end of the day, this is pretty straightforward. We do need to make sure that we get these names correct, the typeset, and so on. There is actually one mistake in this table, which is the relay one should be read and write, not just read only. So we'll really just copy this humidity. We'll come over here and we'll paste that. And then we'll select the variable type. The variable type was floating. If we look back here, it was a float, okay? And then down here, we'll see what kind of interaction we have. We have read only. We're just reading it. We're not writing that. So we can put read only here. And then we'll put periodically and 1 second. Now, this is something that's up to us depending on the use that we're implementing, but we're going to put it periodically, update every second. And the variable showed up here. We're going to add another variable, come back to the list. It's going to be temperature. Okay. It's also going to be a floating point number, and it's also going to be read only periodically 1 second. Okay. We'll keep going. We have light. This time light is an integer. It's also read only. So we'll do add light integer read only. We'll also update. We're going to update most of these every 1 second. I think 1 or 2 of them will be on change. So moist value, not moisture, but moist with a capital or lowercase m and a capital V is also going to be an integer. Add that variable. And it was an integer. So the type integer number, read periodically. Instead of 1 second, we'll do, instead of 10 seconds, we'll change it to 1 second like before. Relay 1 is a Boolean. And this interaction is really whether it's going to be on an update or a change. And so that's what the interaction column means here is if we come back over to here, we'll put in add variable, change it to the type of a Boolean, which is a true, false, or a 1, 0. This one is the one that has the mistake. It's going to be read and write. And then on change is the interaction that we want. Okay. Now, again, add another variable, and this time we're going to be relay 2. In our case, we're going to use relay 1 and relay 2 for the pump and the fan. So I'll change the name here, relay 2. It's a Boolean, read and write on change at variable. RGB color is a unique type specific to the Arduino cloud, which is shown down here as a light in color, and it's called, I think, colored light, but let me double check what it was called over here. The variable is colored light, variable type. So come back down here, colored light. And the colored light is interaction is on, which means on update, and then read and write. So read and write and on change or on update. Okay. Update display, just copy that name, Boolean off, read and write, and on update. So Boolean, read and write, on change. Okay. So now we have our variables, humidity, light, moisture, moist value, relay 1, relay 2, RGB color, temperature, and update display. And those should align with what we have here. Okay. So that's the beginning. Make sure we have the setup right. We're going to come back over to our work instructions, and we'll see how we did here. We have add thing. Okay. We did that. Add cloud variables for humidity, temperature, light, moist value, relay 1, relay 2, RGB color, and update display. Check. We did that. Now we need to associate the connected device. Okay, so over here, if the device was already set up, we're going to associate the device that's the one that we're using. In this case, Hoover Home. Okay. So we'll come back and we'll check that off. Associate the connected device. Then we're going to configure the Wi-Fi network. Okay, so for this, your network is going to be a little different than my network. And so we'll go set network right here. Okay. And network credentials update. There's a slight change in the instructions on this where this Wi-Fi credential is now in the devices page, and it's shown right up here. Okay. And so I have my username and password for my Wi-Fi here. I'm not going to show you that. And we're going to go ahead and we're going to remember that. Remember to go to Sketch tab and upload the credentials to the board. So we'll go back to there. And what this is essentially telling us is the sketch is the code that was developed by each of those steps that we did when we created the thing called urban farming, Hoover in this case, and then it automatically configured a lot of what we need and created some variables. For example, over here in thing properties, we see all of those variables that we just created, humidity, temperature. There's also some additional ones, the Wi-Fi credentials, which are shown over here in Sketch secrets local to the computer, not in code. And then there's some other initialization going on for reading all of those variables and setting them up properly for the Arduino cloud. So we haven't yet run this upload and connect here, but let's go back to the instructions and follow along. So configure the Wi-Fi network. Okay, check, we did that one. Now add a dashboard renamed Urban Farming with switches, gauges, charts, and indicator values linking each of the cloud variables. Okay, so back over here, we're going to go back to our main interface, go to the tabs over here. This was our thing, okay? And our thing has all of these components in it. We've got a device associated. We haven't uploaded anything to the device, we can see the sketch actually for that thing from right here. We can also see the setup here. Okay, so but now we have to go to the dashboard, and we're going to make a dashboard. So we don't have a dashboard in here yet, so we're going to do create dashboard. There, this one, let's see if there's any specific instructions about what to name it. Renamed urban farming. So I'll interpret that and say, okay, I'm going to rename this. I'm going to call it urban farming dashboard, and I'm going to put pen Hoover just so I know which one it is. Okay. Now, how to do this? Okay, so there's an edit functionality here, and we're going to go back to the course and look at what the dashboard is explained as in activity 8. So the dashboard is going to use the variables humidity, temperature, light, moist value, relay 1, relay 2, RGB color, and update display. And it's going to use what's called a widget, the user interface of a percentage indicator, a gauge, an indicated value, percentage, switches, colored light, and another switch, and the range here. So the dashboard will look something like this when we make it. So we'll start with start at the top, and we'll get a humidity variable as a widget that's a percentage graph. So we'll come back over here, we'll do edit, and we will add. We'll see that there's an option, a list of widgets here, including percentage right here. Okay, so this is just a little a graphic that shows almost like around the circle here, the percentage from 0 to 100. We're going to name this humidity, and we'll just put percent here. That name can be anything we want. We're going to link a variable. It's really important that if you have different things in your account, that you choose the proper thing here. As we go through the weeks, there will be many things from other sections shown here. So make sure you choose your section thing, and then also the variable that's associated with it, and then link that variable between the thing and the dashboard. Now, we might have some things that are additional settings down here, like what kind of icon to show. You could say show icon, and you could maybe have a drop or droplet or something like that. If we wanted that, something like that. And you could have it change color based on a certain value. For instance, if we wanted to change color, if it were below 30, something like that, we'll change it to red. Okay. You can do with that whatever you want. Next one is a temperature gauge from -40 to 100. So we'll come back here, we'll do add, and we're looking for a gauge. Okay. Gauge. Okay. We're going to call this temperature. Temperature. I'm not exactly sure what the units are, but I think it is C. We're going to link the variable. And again, urban farming, Hoover is the thing, temperature is the variable, link the variable. -40, bottom range to 100 is what this said to set it up as, and then done. Okay, now it just automatically mapped it onto this. We can move these around. We can change the size of them. We'll make all those customizations later. So after that, we're looking for light, and light is going to be a value. So back over here, we'll add another one. It's going to be a value, which is just displaying a number. Call this light, and I'll put the word intensity because I know that that's what it is. And we're going to link the variable, make sure your thing is set up correct, and then light here, link the variable. And if we wanted to show an icon, I think we could probably find something that looks like a light just for fun. right. I'm not exactly seeing a light. How about that one? We'll call that a light. Um, for this guy, we could have probably put a temperature gauge or something like that. Um, so maybe we'll edit this guy, change the settings. It doesn't give us any icon options. That's okay. The kit instructions go to moisture value is going to be a percentage from 0 to 100. So moisture value percentage from 0 to 100. So add percentage, call this moisture value percent. We're going to link the variable moist value. And done. Next one is relay 1 is a switch. Switch right here. Relay 1. Notice you can have different, spellings or whatever here, but when we link the variable, we have to make sure we use the one that fits us there, and done. Add another switch, if I recall, relay 2, switch, relay 2, link the variable, relay 2. These just automatically popped in right here. We might move them around close to each other, something like that. And then RGB color, colored light. Okay. So this will be an interesting one. So colored light. So we have this guy. Nope, that's not quite right. We don't want that one. So I think we can click this and then delete it. Yes. And then we'll add one colored light right here. Okay. And this is the guy. We're going to link the variable RGB color. And there we go. So this is an interaction where we can turn on and off, and then we can actually change the light color by moving this around, the intensity and the color here. So it's kind of an interesting one. And update display is a switch, okay? And we'll see what that ends up being used for. So switch, and then just title it just like it's named, update display. Link the variable, update display, and away we go. Done. Okay, so we've essentially, with this, we've created our user interface. We can tinker with it. We can move things around as much as we like. And it's really up to you to set it up however you'd like. It really will depend on what you want to do. There's obviously other things in here that we'll eventually use. For example, some charts and other indicators as well. So we'll come back here and we'll say done. So that's our dashboard. Okay. So and this is what their dashboard looks like. So just for consistency, I'm going to put update display, relay 1, relay 2, and then humidity and temperature, moisture value. So we'll try to replicate that. So move this around, edit. Down here, update display, relay 1, relay 2. this over here a little bit. And then humidity and temperature up top. Moist value and RGB color. And we can make these weird sizes if we want. Like that. We can, I think we probably want to keep that one pretty similar. And then over here we have light off to the right. Something like that. Okay, so we have a dashboard that is very similar to the one here. Okay, and so now that we've done that, we've got to actually program the Arduino to do what we want it to do. Now here, this is going through and describing the setup. First, it's going to be thing properties.h, and in the include or the libraries, Arduino maker IoT carrier.h, and then maker IoT carrier is the set of functions that run this IoT maker carrier, the moisture pin, and then defaulting the relays states to a string that's just empty, which will be used for printing out diagnostically. In the void setup, we're going to use the carrier case variable, set the case to true. We're going to set it to false. We'll fix that. And then there's the carrier begin function that allows the carrier library to start and begin the serial monitor. And that happens with a diagnostic check of the Arduino cloud connection. That's what we have here. When things are working, we're waiting for connection right here. And so then in the loop, we can have if-else statements. And so we can make some if-else statements related to the relays and relay 1 and relay 2 states. And we can read the light, temperature, humidity. We also can map the moist value, the number that was read from the moisture sensor. We can map it to 0 to 1023 to 0 to 100%. And so we'll essentially do that for now, but we're ultimately going to recalibrate this moisture to height relationship when we use this. And honestly, 0 here as the minimum for the moisture sensor. Ours were probably around the 700 minimum. So we might change that to get this 0 to 100% scale to read. In the loop, we have Arduino cloud.update. And if relay 1 is true, then we're going to open the carrier relay 1. And we're going to set the string for relay 1 to on, just something that we can display out. And then relay else, relay 1 is closed, relay 1 state is off. And then relay 2 equals true, and so on here. Okay, so this is essentially looking at the color for the LEDs and reading the temperature and humidity, reading the raw moisture value, and then mapping the moisture value here. So underneath each of these functions is several independent functions that say what to do when the relays are changed. Now, these are actually automatically inserted in the code in a blank form like this, the part that says do something, when we set that interaction to on update in defining the variable. Now, this is added in for the RGB color, which says to change the color of the LEDs here. Okay. And so on update display, which is the LCD display, we're going to show a white screen with red text. We're going to show whatever text that we're interested in, including temperature, humidity, light values, moisture, and then the relay states right here. So this is all of the diagnostic. Now, these are step-by-step code that could be added into into the Arduino. Now, I think the code is down in here, and actually, if we say enabled teacher notes, I think we actually get the code that we can copy completely. Let me double check that. Actually, I think it's a little farther up here above all of the explanation of each block of code. Okay. So this part right here is where we learn about inserting the code into the sketch. So we're gonna essentially copy this snippet of code right down here. Okay, keep copying down till we get all the way to the bottom of the code that's already been written for this activity. So now we're down at the update display, should probably be the last thing in there. And we'll come back up and make sure we go not going further. So I'm just going to do Control C and then come over here. Now here's our dashboard, but what we really want to be in is our thing, okay? And in our thing, we want to go to our sketch. Now the slightly intimidating thing here is that all this code that was written previously, we want to scrap it. And we want someone to take all of this code right here that was automatically inserted, and I'm going to delete it. And then I'm going to take all that I copied, and I'm going to make sure I got my curly bracket closed down here. And then I'm going to go through and look and make sure that all of my code is coming in here correctly. There's a few things I'm going to change. For instance, I'm going to change the carrier case to false. So no case. And I'm going to change my moisture scaling. 700 to 1023 is going to be 0 to 100%. Okay. Now, these other variables over here, this one is just a README that explains how to use this file and how to use this interface. This one is the one that was already set up during the thing creation process. And hopefully all these variables are consistent with the ones over here. So just for checking, we're going to go back to our step-by-step procedure, make sure we're on the right track here. So we added the dashboard variables here. And so we're done. Oops, we won't do that one. We're done with that guy. Okay. And now we're going to link moist value with a moisture millivolt gauge ranging from 600 to 1200. Okay, interesting. See what that is. A gauge ranging from 600 to 1200. Okay. So back on the dashboard, I think what we need to do is modify that a little bit. So over here, moisture value was currently showing as a percent. And if I'm reading this correctly, we're going to modify that to show this as a gauge. And so we'll come back here and we'll edit this. We'll add a moisture value gauge right here. Moisture value millivolts. And we're going to link the variable moist value. Link that. And the gauge was going to be 600 to 1200. Okay. And done. Okay. So we could put that wherever we want, but let's put it maybe close to this guy here. This guy. And we'll say that's done. Okay. So link moisture value with a moisture millivolt gauge ranging from 600 to 1200. Add a temperature chart and rearrange the dashboard. Okay, getting creative here. So we're going to add a temperature chart. I think what we might do is put it down towards the bottom. So we'll take temperature, make it a chart. We're going to add this variable over here. Temperature, C, link the variable, temperature. And we'll leave it as a, well, let's set it as a line. See what that does. And then we can drag this over here. Farther. We could probably move this up a little bit. This guy. This guy. So it's a little easier to see all this. So you got a temperature chart down at the bottom. Okay. Okay. So we already did copy paste the Urban Farming 101 code into the sketch. And then it says add a line, a code line that says moist value equals a raw moist value. So we're going to copy this line right here. So we'll go ahead and just get this guy, and we're going to copy. Hopefully we'll copy this guy with the semicolon. Copy and then put that into the sketch. And we will certainly want to put that down in the loop after that moisture value is red. So I think we want that right there. Moist value equals the raw moist value. Okay. So essentially what that seems to be doing is skipping our mapping here. So let's make sure that we have that correct in what we're intending to do. We'll look at the slides. Do we need a moisture? We don't really need a moisture gauge. We're going to remove the moisture gauge and just show the raw value. We're not going to show the percent. So that makes sense. Here, we're going to edit this. We're going to take this moisture, delete that. Okay, and then pop that over here. And all that done. And then back over in the code. Back to our thing, urban farming. In our sketch, we're going to use a comment to comment out this line because we're not reading it as a percentage. We're just going to read it and show it as the raw value. Okay. So we're close to completing this block of code. Next is verify and upload the sketch, verify sensors, dashboards, and functions work properly. So all of this does automatic saving as we go. And so there's not a save button. So this is our first step, verifying the code. Okay, it verified. Amazing. Cross your fingers. Upload. So now via serial port, we're now uploading that code to the Arduino Maker carrier. We hear the relays clicking a little bit, and somehow miraculously, this thing seems to be doing something. So let's go back, follow the instructions. Verify and upload the code. Okay, well, let's actually use our highlighter and it's clicking at us. Interesting to see what that's about. We'll see. Verify sensors and dashboard functions work correctly. Disconnect the USB cable from the Arduino. Well, let's see. A couple of things we could do. One, we could actually take a look at the serial monitor because there were some diagnostics that were supposed to be coming across here, across the serial port when things were running. I don't see anything in here right now, so I'm not sure if that's a good sign. Probably not a good sign. We do now see we have a cloud option, which is because we put in Wi-Fi credentials. We can actually run this thing wirelessly over the air. But I think what we really need to do is take a look at our setup and go back to the thing. See if these variables are doing anything. So we do have some variables showing right here. That's a good sign. Maybe, and that light even changed. So let me cover that up and the light goes down. That's even better. Okay, so let's take a look at them in the dashboard. See if our dashboard is doing its thing. Okay, so some of it is working. Let me try to increase the temperature. I'm not seeing any increase in temperature. Now the water sensor, it's going to be a little hard to change because it's reading 1023. I don't have any water in the tank, so I'll have to fill that up. But let me try the colored light. I'll turn the light switch on. Okay, and as you can see right here, I'm seeing some light, and I can actually try to set the color, change the color a little bit to blue and then green. The green looks a little pink here. Red. That doesn't look red, but nonetheless, on, off. That's working. If we update the display, will that make our LCD display change? I heard something. Okay. Heard a relay. It doesn't seem like it quite worked. It almost seemed like the update display is tied to the relay variable. And then relay 1 didn't do anything. Relay 2 didn't do anything. So we have light intensity. Humidity doesn't seem to be working. I would expect it to be a little higher than that. Light seems to be working. One of the things we can try to do is we can actually pour some water in the tank here. And I'm going to go ahead and pour a little water in to see if our moisture sensor starts to change. It's still just below the tip. Oh, there it goes. So the moisture sensor is changing as my water height increases. I'm at about 1 inch, 1 1/4, 1 1/2 right there. And my moisture sensor is in fact going down with the water in the tank is filled up a little bit. So that's a good sign, but these other sensors aren't working. So this is actually kind of one of those things where my best bet is to try to re-upload the code to see if these temperature sensors start to work here. I have no idea why they're not reading, but that's my best guess as to the step-by-step process to get them to work properly is to re-upload the code. Make sure everything's good here. Come back to the things. Make sure I've got my variables all squared away. Um, And then I'm going to come over here to sketch and let's see if the serial monitor has anything. I don't see anything. So I'm going to go ahead and do upload again. The environmental sensors are called Bosch sensitronic sensors. And we have experienced a number of times where Bosch will update libraries and that will change whether they work or not. Here, we're now starting to see the display is actually reading, waiting for connection, okay, which is what we're hoping to see. So that's good. Another diagnostic is we can see if the serial monitor is displaying anything. And we can see here that it's showing some diagnostic information here. Who-hut5 failed. So the essentially maybe the Wi-Fi connection, the Wi-Fi password that I put in, perhaps is not the right one. Maybe I didn't actually put in the password. So that's interesting. So maybe we'll have to come back and deal with that. Let's, in the meantime, come back to the dashboard. And let's see if any of our sensors are working now. So let's do update display. Update display does not change this guy. Temperature, light. Yep, nothing seems to be working. So it seems like maybe our wireless connection is the problem. Hard to tell, it worked before. So I'll come back here. I can see that I have a COM port connected here, but not the cloud connection anymore. Metadata here. Not much to see about that. Serial connection. Oops, that's the download. Serial connection is still showing who-hut5. That's my Wi-Fi. Does not like this device. So devices. I'm gonna edit this. Okay, so I did a little diagnostics, and what I did was I realized that I had never uploaded or saved my Wi-Fi credentials when I was in the device section, and under device, there's a Wi-Fi connection here, and I had never done save and upload, or save and upload later. After I did that, I went back to the thing, and then I went back to the sketch. And I re-uploaded, and now things do seem to be working. I can see the serial monitor, and there's nothing coming across here right now, but we can go and see under the dashboard if there's any activity, and hopefully there is some. Okay, so now we have an active dashboard. Multiple instruments do seem to be working. I'm going to put my finger over the temperature sensor, and On the screen, I see it climbing 30, 30.6, 30.8, 31. That's good. Okay. I'm also going to blow on the humidity sensor. And you can see the humidity going up. Now, the moisture sensor, it's at 850. I'm going to pour a little bit more water in and see if that number goes down a little bit. So that's working. And also on and off LEDs are working as well. The light intensity continues to work. If I cover it up, the number goes down. If I put a brighter light on, it should be a little higher. Now, update display is there's a small display on the screen here that shows temperature, humidity, light, moisture, and then relay one on and off. If I update that, that just diagnostically updates each of those values. Now, relay one and relay two are right here. They're tied to the yellow lights or the LEDs on the bottom of the screen. So let me turn on relay one. L1 is on, off, L1 is off, and relay two on, relay two off, and away we go. We can see the temperature chart is displaying as it should be down here. I thought in this code we had some diagnostic information written out to the serial port, but that was only really if there's a connection issue, which is what we saw before. So we are now connected and everything's working. So we've accomplished quite a bit in getting this dashboard to work. Coming back over here with our highlighter, we'll go ahead and verify sensors and dashboard functions work properly. Great. Now we're going to disconnect the USB cable from the Arduino. So here we go. Disconnect. And then we're going to connect the short red and black power cable between the Arduino and the Maker Carrier. Now ours is already on here. That's the battery power jumper there. And then insert the 3.7 volt battery, ensuring plus is on the plus side. So we'll put our battery in here. Okay. And okay. Now it says ensure over the air Arduino Maker Wi-Fi 1010 on the thing sketch and re-upload the sketch into OTA mode and ensure the dashboard works. So we'll come back over to the dashboard. We can see nothing is working right now. We'll go to thing and we'll come over here. We'll take a look at the sketch and interestingly, we do not see that little cloud connection there. So I think diagnostically, we will go ahead and try to connect our serial port here. It is possible that there's just a delay issue with getting it connected. So now that the serial port is connected, the USB port is connected, now we see this little option right here. And so now we've changed the associated device to the cloud. Okay. And now we're going to, it says, upload the code. In the diagnostic window down here, it says over the air upload request created. And so theoretically, that's using the Wi-Fi connection to upload this code. When I've done this before, this does tend to take a bit more time in uploading, going over Wi-Fi. I'm gonna reset the Arduino, see if that does anything. Didn't seem like that upload was working properly. We'll go back to cloud here, stop that, and then we will try again. I'll try to be a little bit more patient this time. Okay, looks like it was successful. Over the air upload update successful. That's what it's shown down here. That's good. Okay. We're still seeing it say wait for connection, waiting for connection. Interesting. So see if we see anything on the serial port. No activity here. I'm gonna try to now that it's uploaded successfully, I'm gonna try to disconnect, and I see that the screen still shows the same thing here. I'm gonna go ahead and just reset this guy and see if that allows everything to come back up. I do see the over the air here. So I'm not sure if it is actually communicating over the air, but the best way to find that out is to look at the dashboard. Fingers crossed that things are working. So I'm going to update display. That's not doing what it's supposed to. Uh, Temperature, light, none of these things are actually working as they should. So difficult to tell whether or not to be more patient with this and see if there's a Wi-Fi connection issue that just needs some patience to resolve. It does say the device is connected here. And that's good. And we've lost our little connection tab here, though. Change the associated device from the setup tab. Let's see about this. This guy. Setup. Does see that our device is offline. Change network. Go to device page. Okay, so our history here. The OTA update was successful at 9:05 p.m. So that's good, but where is it now? It's hard to say what's going on here. So let me just try to reset again on pressing the reset button on the bottom. See if that does anything for us. And the Hoover home device is online, and it is associated with the urban farming thing here. It does still say waiting for connection though, which isn't a good sign. Oh, but the numbers here do seem to be changing. Okay, maybe just resetting was all we needed to do. So let's go back to our dashboard and see what we see. The interesting thing now is we're entirely on battery mode, so there's no wires connected here. Hey, and our sensors are working. I'm going to put my finger over the temperature sensor, and we start to see the temperature climb a little bit. Finger over the light sensor and back. Moisture sensor, we'll add some water. See if the number goes down. And then light. Okay. We'll update the display, and there it goes. It updated. We'll turn on relay 1, turn on relay 2, turn off relay 1, turn off relay 2. So whatever the dilemma was, it now works. All I did was reset the button on the back of the Arduino, and everything came back on. That is going to be some of the mystery of working with this device. Please be patient. Now, if the Wi-Fi connection doesn't work for one reason or another, make sure and first just check the password and username. And then if it still doesn't work, just go ahead and use this connected to USB. We can run this entire experiment still on USB. It doesn't have to be wireless. That's just sort of convenience for us. Now, if we are connected to USB, that will also have the bonus of charging the battery. So that's a nice thing. We've done an awful lot here. And so now we have ensured that the over-the-air is connected, and we re-uploaded the sketch. Okay. We tested relay 1 and relay 2 switches, and they illuminate LEDs 1 and 2. We want to recalibrate the moisture sensor by adding water to the tank in 0.25-inch increments and recording moisture. And then from that, we'll also do a log calculation, probably in Excel. We'll use regression to figure out the slope and intercept. And then the next thing we're going to do is we're going to use jumper wires to connect in the pump and the fan to these guys. Now, there's a little connection in here that's a quick connect. The wire goes in the bottom port here, and then if you want to release it, you can stick a small screwdriver or pin in there and then release the wire, and that will allow the relays to work. I think right now I'm going to pause before getting into that. I will just show those things in this part of the manual for the course, where we can see that in order to make a light bulb go off, for example, we have to connect a battery and use the relay as a switch. In our actual lab, we have the details of that laid out here. This shows how a electromechanical relay works, and then a solid state relay doesn't have all these moving parts, but it works essentially as a switch. We're going to use the battery as our power, and so here for the pump, we're going to have a yellow wire coming out of the middle or the COM port of the bottom here, going to the black line on our pump. which is the ground essentially. The red line on our pump is then going to come in here, go to the positive battery, and then the green line is going to come in here and go to normally open. Okay, so those are the components of making the pump work. So we have little pump wires here, and we also have some jumper wires. So we'll use the same colors if we can for this. We have I said I wasn't going to continue this, but I think for now we'll just go ahead and get this working while we have it. So wiring up the relays, flip this guy over, and we're kind of zooming in here. We're going to take a small yellow jumper. We're going to go right into the bottom on the middle, right here, and then a small green jumper wire. And we're going to go right into the bottom side, the normally open pin. Okay, now we're going to get the ends of our leads for our pump, and we're going to use a yellow jumper to go from our black line here to our yellow jumper here. We'll try to not let these wires touch each other. And then we're going to take this green line. We're going to jump this guy from this little green jumper with these alligator clips to the negative side of the battery, which is on this one, it's the black side down here. Okay. And then we're going to take a red wire with a red jumper, and we're going to connect up the plus side of the pump to the plus side of the battery. Okay. Now with this working, essentially in our setup over here, we have a vat of water, a beaker of water that has the hose from the pump going from the pump into here. And if we turn on the relay, I believe that one is relay 2 is the one I wired it to our dashboard. Relay 2 should turn on the pump and off the pump. And there it goes. Now, water is pumping and back out. A few things to be careful about as we're moving water around is now we have electronics and we don't want to get the electronics wet. So we want to make sure we're using a little clip to hold the tubing in. We want to make sure the tubing doesn't end up siphoning and flowing back into the tank or anything else weird like that that would cause water to get on things. We can do the same thing for the setup for the small fan. And in that case, we can just use relay 1, and this connector down here, which we could connect up to make that guy work. So at this point, we have we haven't done the recalibration. We have used jumper wires to connect relay 1 to the pump. We actually, in this example, we connected relay 2. We'll just need to be mindful of that as we do anything else. And then we tested the pump. So we sort of did these 2 steps right here. So I think that's where we're going to pause right now and call that a day. Okay, as we pick back up, we're going to notice a few things. One, I've done a little bit of work on the relays where I've connected up the relays. Relay 2 and relay 1. Relay 2 is connected to the fan, which is on top of the tank on my case. Yours might just be loose, sitting around. And relay 1 is connected to the pump. Now, the wiring schematic that's shown is, in fact, helpful in terms of the color coding and so on, yellow and green wires and jumper wires and things like that to to connect this up, as shown here. So these green and white wires, green and yellow wires here, and the instructions that are shown here are all very helpful, except the notes show relay 1 connected to the pump, and the picture shows the upper relay, which is actually relay 2 connected to the pump. So you can use whichever one you want. I've done it according to relay 1 is the pump, relay 2 is the fan, following this wiring here. So yellow goes from the COM in the middle of the relay, 3-pin connector to the pump, black, and then the red positive power from the pump goes to the positive side of the battery, and then the negative side of the battery, the green, goes to the normally open terminal, the bottom terminal on the relay connector. Now with the relay on and off, there's yellow indicators on the bottom, or really the top of the Arduino IoT Maker Carrier, and you can hear the relays click. But when the relay, when the IoT Maker Carrier is upside down like this for the wiring purpose, really you don't see these relays, so you can just diagnostically run the cloud dashboard and see what happens. So if I run relay 1, that'll turn on the pump, and I turn it off real quick, and then relay 2 turns on the fan. You can't really see it, but there is a fan spinning right now, and when I turn it off, it's a little baby fan, turns right off. So the relays are wired, the pump, the fan is wired. And now we're going to go back to the part of the step that says to calibrate the moisture sensor to water in the tank from 0.75 up to the top in 1/4-inch increments. And so I've already set the water level to 0.75 by turning on and off the relay to pump water out into the container here. And so what we're doing is we're going to go back to a few slides down, and we're going to take a look at this data from the previous lab isn't quite linear, and so we see that a log-log relationship is a little bit better of a fit. But really, just redoing our calibration for the tank as opposed to using the water height gauge or the height gauge from the previous lab. This is just going to be more helpful for setting water height for our tank, just reading off the ruler on the side here. What we want to end up keeping is 1.5 inch plus or minus 1/4. So we're going to use a 1, 2, 3, 4, 5, 6, 7, 8-point calibration essentially, and fitting our data to this. When we fit that data, we're going to use a spreadsheet. We're going to take the log of height and log of moisture, and then ultimately computing the slope and the intercept. And then we're going to use a function like this to determine the height for our from our moisture sensor readout. So to that point, we're going to come over here, and I think it might be helpful to stop sharing for a minute, just so that we can get a little bit more of a zoom in on this tank. We have the IoT Maker Carrier here, the battery clip, negative and positive. Be a little careful with these connections. You don't want the wires to touch or cross, especially these alligator clips that have open terminals here. You want to make sure that the positive and negative doesn't short. It's just going to cause the battery to drain quickly. If it does, it could also damage the fan or the little pump that's inside of here. So these wires are kind of masking some of what's going on here. So I might just put this to the side for a moment and try to move this to the side so you can see the tank, and it is about 0.75. So really, the next bit is to go ahead and let's get this back over here. Is to go ahead and pump this water, fill this water up with just manually filling it up with a funnel and pouring water in, and go take readings at 1/4 inch at a time. So come back to sharing the screen. And we'll make a spreadsheet here. Moisture sensor tank height. We'll have height in inches, moisture, we'll just call it that in millivolts. Okay. We're also going to have log. It's really log base 10 of height. And also log base 10 of moisture. Okay. And so we're going to look for an increment of 0.75. And we're going to try to get up to, let's see, 2.25, 2.5. We'll see how high we can get on this guy. So was this plus 0.25? Oops. Equals this plus 0.25. Okay, we'll see if we can get up to 2.5. That's going to be pretty high. And we'll make a table here. So try to format this a little better. Okay, so let's take a reading. Well, we're at 1023. So that's going to come over here. And this will be 1023. Then we're going to fill up the water to the 1-inch mark, approximately. We do have to be a little careful with not jostling the water around too much. And I'm just pouring in some water. Okay, right about there. Get down. Use a little bit more. This is one of those sources of error with the visual reading. And now we're down to 943, 944. So take the last reading we saw, put it right there. Now we'll go to 1.25 inches. Trying to be as careful as possible. Get down to a little bit more. Right there, 1.25 inches. And we'll take our reading from our cloud dashboard. 884. Let's jump in a little bit. 884, we'll call it that. And we'll go up to 1.5. Now, if we ever go over the number that we're shooting for, we can actually just run the pump and pump it back out. I always seem to be a little under. So just looking at it from a higher perspective, get down a little bit more. Right at 1.5, which is really the set point that we're going to try to be keeping. 845, 47. We'll go 846 was the last one I saw. And then 1.75. Arduino dashboard is now down to 819. So 819. We go up 2 inches. Right at 2. 5 dashboard reads 802. Kind of the average right there, 802. And then we can go up a little bit more. We do want to be careful and not overfill the tank. We also want to be careful and not have the moisture sensor signal electronics get wet. So 2.25 is, which is really right under the cap there, and we're at 791. Went down to 790 last. But now we'll just try 2.5. This is pushing the limits on the height here. Really pretty close to overfilling there. So we don't necessarily need to have the 2.5 measurement, but since I'm there, 780, jumping around, 782. We'll just go with that, 782. Okay, so this is actually our calibration. We could repeat this if we wanted to. If we were to plot this, we probably would see that logarithmic curve that we've seen a bit before. And of course, it depends on the scale that we're setting. I would really swap the height and the moisture axes because we really want height as a function of moisture. But in general, this is the curve we're seeing. If we change this axis, the minimum here, down here, we could probably change the minimum to 750. Oops, not that 750. That helps us see the relationship a little bit more, but ultimately, what we really want to do is to compute the slope of the log-log relationship. Okay, so here we'll do equals log, and I'll just be explicit with a 10 to make sure the base is 10 of this guy. And then we'll autofill that. And then we'll also do equals log 10 of this guy. And also autofill. Now, these numbers are probably too much precision, so we should probably set the number to something like that, maybe increase it one more, something like that. Okay. So if we want to compute the slope here, we can use the function equals slope, and then our known y's and our known x's. So y is going to be the variable that we want out of from the input. So well, let's assume that the input is the x of moisture and the output is the log of height. Okay. Oops. I didn't complete that. What's that? Data is unknown. I'll just delete that. Try it again. Equals slope. And there we go. Comma. Our x's, close paren, equals. So this is our slope. And our intercept equals, we can just use the intercept function. And our known y's, comma, unknown x's. And close paren. Intercept. So we might use something like that. So if we were to then put this into the form of getting the y out of here, we would use our power function, our exponent function. So going back over here, what we see here is then the slope, which is minus 4.35 in our case, and intercept is 12.896. We're gonna have a function like this: height equals pow with the base 10, comma, parentheses, minus the slope times log 10 raw moisture value plus the intercept. Okay, so this is just a screen grab of this. So we have raw moisture value here, and so we're going to compute height from here back in our code. And of course, we're going to need to update that into our sketch. So let's go, and we'll go back here. We'll go to our things, Hoover, go to our sketch, go down within the loop, and right down here, we are going to have height equals pow 10, comma, and then we'll go back and take a look at this. Parentheses minus the slope, or the slope times log 10 of raw moisture value. So back over here. So we'll put in the slope in our case is minus 4.325. So minus 4.335 times log 10 raw moisture value, okay, times log 10 of raw moisture value, RAW, moist value, close paren, plus the intercept, close paren, close paren. So that. So plus our intercept, close paren, and now we need a semicolon at the end. So we've just defined height as a function of log moisture value. Okay. So this is our new height variable. Now we haven't actually created this in the thing, so we're going to need to do that as well. So let's go back to the work instructions here. So we had we're on our highlighter. Recalibrate the moisture sensor by adding water to the tank in 0.25-inch increments. Recording moisture. Okay. Yeah, we did that. Good. Good. Compute log base 10 of height in inches and moisture voltage. Check, we did that. And now use regression to compute the slope and intercept between log inches and log millivolts, the y and the x-axis, the y and the x variables, respectively. Okay, we did that. So we have also already used our jumper wires to connect up our pump and our fan. So let's go ahead and highlight that. I've got relay 2 connecting the fan, and then demonstrating the LED lights turn on and off with colored lights. We actually already did that, so we're good with that. Now we can come back here if we really want to, just to make sure we're explicit with that step. We can come back and go to the dashboard, urban farming, and without messing up our wiring too much, we can come back here and we can turn on our lights, and we can tinker with some of the colors, change those, and yep, our lights are working, our LEDs are working. Also, we should be able to see our relays working underneath. I'm not going to turn them on just to keep the water level right now where it's at. Okay, so back to the checklist. On the urban farming thing, add the cloud variable height as a float, read only, periodically 1 second. Height set point as a float, read and write, periodically 1 second. And error as a float, read and write, periodically 1 second. Height underscore set underscore point and error. Okay, so to do that, we're going to come back to the thing. Go to the variables. And we're going to add height. Okay, that's going to be a float. And it was read only, periodically 1 second. Add variable. And then we had the height set point. Height underscore set underscore point. So we'll do that. Height underscore set underscore point. We'll set this as a floating point. We'll read and write periodically. It's important that we can also read and write that because we're going to use a slider to set that. And then we're going to add error. And that's also going to be the difference between the height and the set point. That's also going to be read and write is what it said previously. Read and write periodically 1 second. Some of these things could, depending on how it's programmed, be changed a bit, but let's follow the instructions there. And what that did do is it put those guys here, and it actually also put variables into our code over here. So for example, that height variable that we just programmed, it wouldn't have worked in the program the way we put in that that new calibration of log scale if we had not just declared it. Okay, and so it's now part of our cloud environment. So we'll take our highlighter and we'll highlight over these guys. Okay. Add a sketch line to compute the height with the slope and the intercept. So I was a little bit ahead of myself on the last one. In this case, I've got my own intercept and slope there. Upload the modified sketch over the air. Okay. So let's try that. So we'll go back over here. We'll first verify this guy. And then we will upload over the air. I do actually have my USB connected on this one right now. Usually when it's connected, it shows charging right here, so I'm not sure why it's not showing that. It might be that it's because the battery is already full that it's not charging. But I like to keep that connected to charge the battery, especially when I'm running um, the pump and the fan, and eventually that battery will die out. So now it's rebooting the device. Um, so I do have this turned upside down, so it's going to be a little difficult to see anything here. It has the update information of each of the indicators there, but we could actually also keep an eye on this as it's uploading, and then when it seems like it's done, we can switch over to the dashboard and see what we have. We do now see our charging indicator light here for the USB, which is interesting. Again, we should also note that our water is actually at the very tippy top um, of our reading here. Okay, it does say over the air updated successfully. Maybe we can close out of that one, come over here, and we'll go back to our dashboard and see what we see. Is it active? Okay, it does look to be active. So a little bit of diagnostics. Put my finger over the temperature and see if it starts to go up. It is going up. I'm also going to turn on the lights. They're coming on. Okay. And I will update the display. And it does change. Off, update. Okay. I'm going to turn on relay 2, which is the fan. Okay. And before I turn on relay 1 to pump out the water, I'm just going to go back and look um, at the information here on the instructions for the procedures. Okay, we just did the upload the modified sketch over the air successfully. Now it wants us to change the dashboard a bit more before we do anything else. Add a vertical slider to the dashboard linked to the height set point variable ranging from 0 to 3. So let's go ahead and edit this. I have a feeling that we're going to need to do some rearranging and cleaning up and modifying this to get everything to fit. So we need a slider. Right here. And so vertical, okay. And this range is going to be 0 to 3 inches. Okay, we'll get this out of the way. So height set point. Inches. Length of variable. Height set point. And the range 3. Done. Okay, so we can have this guy anchored around. Okay. What else? Okay. Add a value indicator to the dashboard linked to the error variable. Okay. So add a value. Call this error inches. Make this right there, like that. Decimal digits, truncate rounds. I think we'll just leave it like that. So we have error down here. Okay. Check that. Add a height gauge to the dashboard linked to height. Okay, add a height gauge. So a gauge. And height gauge. Inches. To the variable height. The range, probably again 0 to 3, something like that. Okay. Add an advanced chart to the dashboard linked to the height line and the height set point. Okay. So just to consolidate things, let's move these guys up a little bit. Consolidate. Consolidate. And I think for this one, I'm gonna change the name of that. Change the name to be relay 1. We'll just call this pump. Done. And this guy, we'll edit. Call this fan. We'll make this little light intensity graph, which is not that important. We'll just move it over, pop it down here. And not terribly worried about that one either, but let's go ahead and move some things over. Temperature. Moisture value. Error. Make that fit. Definitely gonna have to do some rearranging. Make all this work. Just try to get things that are kind of more of a priority into the center of the screen here. And things like that. And in way, shape, or form, we'll have to get this over here. And then we're looking to add an advanced chart. In this case, this is height control chart and link the variables. we can select more than one. So we're going to do height and height set point. And we're going to link those variables. This guy, let's see, height set point, we'll call that the red as a line, and then blue for the actual height. And we'll see what that looks like. That would be kind of cool. There's some other settings on that. Looked like there was a setting to actually like have more of a fill in, like an area. Let's go. This one is more of an area. And see what that looks like. But we do want to put this up. We want to have this done. Let's put this up to 1.5. Our current height is actually reading up higher. So interesting, our calibration is showing our height up here. It's really 2.5 right now. And so interesting, the red line. What am I showing here? Height set point is 1.5, and then the height, average height. I wonder if I'm doing this right. The average height up here is showing 2.5. So maybe we'll tinker with this a little bit more. Edit. This guy, edit. This guy. So an average or maybe for this one we just want this line and this line. I feel like I don't have the right variables. Height, set point, and height. Do I have the right variables? Show y-axis on chart, multiple axes. No. Done. There we go. Okay. So as we move the height set point down, oops, this has to be off. Have this height set point down. That'll step down there. Height set point is 1.5. Error. We're going to put our error, we can set this. We're going to set our error tolerance of 0.25. Okay. That is a set point that's going to be used for our control algorithm eventually. And as water goes up and down, we should probably see this go down. So let's go back to this. We've done that. Demonstrate the working height gauge while operating the pump manually with relay 1 switch, with and without water flowing into the tank from the rain barrel. And then after that, within the void loop code, program a Christmas tree LED. Okay. So for now, we're going to just we're going to go ahead and work on demonstrating the height gauge. And I think the simple way to do that will be to see what happens when we turn on the relay while we're running this thing. Okay, so there's a bunch of wires in the way here, but give it a go. We'll try to keep this little tank over here. This tank is it's kind of our filler tank where the water's going into. And if that's the tube is coming out of here and into here. So let's see what happens. We're looking for this blue line to change as we turn on relay 1. So something is amiss here. Checking my wiring, I see I have a jumper wire that's disconnected here. So that was connected to my negative battery clip. Okay. So now that we've got our wires connected, turn on our pump. Interesting that the height gauge actually looked like for a moment it went up there. But water is definitely going out. So it settles. So one of the interesting things here, we're down about just over under 2.25. We're reading about 2.25, but momentarily when we turn the pump on, we have noise. Okay. And in other words, that interference causes that signal to go up. So even though the water is going down and eventually settles down, by having this pump, which is a motor, electromechanical motor in the water, okay, and running with electricity, there seems to be noise, which is picked up on the capacitive moisture sensor. Now it's stabilizing now, but I'm going to turn it on again. And we definitely see that sensor looks like it goes up before it goes down, even though water is clearly pumping out. It's stabilizing now just below 2 inches, about 2.9. Yep, and that's what it shows on the gauge. I have to be a little careful here because I am filling up this tank on the side here. Can't really see it in view, but it's getting full. Okay. And so in general, our pump is working. Okay. And our set point is pretty close to that. Now we haven't actually done anything with this error, but I think at this point we're going to call that a night because we got a little bit more to do, and so that's about as far as we're going to get right now. The next steps will be when we pick this back up to program the Christmas tree. Okay, that'll be good. Noting the interference signal induced in the moisture sensor, and then program an on-off controller with the sketch regulating the water level at 1.5 plus or minus a quarter inch. Now that is going to be our big challenge. And so we're going to test this at different water set points and errors. And we're going to tune and troubleshoot the controller. We want to avoid any chatter in the pump and in the relay because that will ultimately reduce their lifetime. And we want to then demo this with 2 full cycles of operation where we pour water in and we see what happens if we can actually keep up and regulate the water. So those are our next steps. We've gotten pretty far here on the Christmas tree light. There's some code that's already provided right here, and it's just a snip of that. That code needs to be included just below the height function. And then the real challenge, now that we've gotten this far, is actually programming the logic for our on-off controller. And the pseudocode for that is right in here. It requires if statements and nested if statements, capturing the 4 states of the hysteresis loop of on-off controller. We either are off and we stay off, we're off and we turn on, we're on and we stay on, or we're on and we turn off, depending on the state of error. So that's where we're going to leave it today. That's a good stopping point. And we've made great progress in our urban farming fluid level controller. Now we just have to finish it out. Okay.